In these particular problems, what we'd like to do is we'd like to multiply binomials. Remember, binomials are two terms that are added or subtracted together. So like the x plus 5, we have an x term and a 5 term. The x minus 3, we have an x term and a minus 3 term. And so as we go to look to combine or multiply these, each of these are a binomial. We want to multiply them together. Now, normally in the last section, we learned how if you have a number that's being multiplied outside of a set of parentheses, so for example, if we had something like 5 times x minus 3, what we would do is we would take the 5 and multiply it by the x, and then we'd take the 5 and we'd multiply it by the minus 3. And we would get this new expression here using the distributive property. Now, in these cases, we're actually going to use the same principle, believe it or not, but the problem is instead of just having one number that's being multiplied by the expression, I actually have an expression that's being multiplied by an expression. I have this binomial that's being multiplied by this binomial. We're still going to use the principle of the distributive property, only I have to multiply the x by whatever it's the first term at the very beginning needs to get multiplied by both things in the next parentheses. And whatever is in the second term needs to be multiplied by everything in the parentheses. So essentially, it's just a fancy expansion on the distributive property. What we want to do is we want to multiply whatever is out here. Each of the things in the first parentheses needs to get multiplied by each of the things in the second parentheses is really what it boils down to. So for example, here we would do x times x, which gives us x squared. X times minus 3, which gives me a minus 3x, plus 5 times x, which is plus 5x, and plus 5 times minus 3, which is minus 15. Oop, lost my 1. Okay, so this is going to be what we get when we multiply it out, and this gets rid of the parentheses for us. So you just have to make sure you remember to multiply both of the pieces if there's a set of parentheses that's being multiplied by a group. Now, don't forget when you're done, your answer's not finished if there are still like terms that can be combined. In this case, I have a minus 3x and a plus 5x in the middle that I can put together. Negative 3 plus 5 is a positive 2. So I end up with x squared plus 2x minus 15 as my solution for multiplying that set of binomials together. This process of kind of this distributive property of each of those things is often referred to by many math instructors as the FOIL method. The reason that they use this crazy term is F means we're going to multiply the first thing in each set of parentheses, so x times x. O means that we're going to multiply the things in the outsides of the parentheses, so the x and the minus 3. The I means we're going to multiply the insides of the parentheses, so the 5x, 5 times the x. And the L means we're going to multiply the last things in each of the sets of parentheses, so 5 times the minus 3. So if you ever hear me or anyone else refer to the FOIL method, it's just reminding you that you have 4 different multiplications that you have to do when you're kind of doing this fancy distributive property. All right, with that in mind, let's try a few more examples and just make sure you see how this works. So here we have a 2x plus 5y, and we want to multiply by 2x minus 5y. Because it's a set of parentheses here, whatever is outside has to get distributed, so we're going to have to distribute both the 2x through as well as the 5y through. So let's go and do that. 2x times 2x, so the firsts, when we multiply that together, 2 times 2 gives us 4x squared. Then we're going to multiply the lasts, or the outsides. 2x times minus 5y gives me a minus 10xy. Then I multiply the insides. 5y times 2x gives me a positive. 5 times 2 is 10, and then y and x. Now, I'm going to write this as xy. Keep in mind when you're multiplying, you can multiply things in different orders and still get the same solution. 3 times 5 and 5 times 3, for example, mean the same thing. And usually when we're writing terms, we like to write or when we're writing variable expressions, we like to write them with the lowest letter of the alphabet first, so we put them in alphabetical order. Then for the next part here, we're going to do 5y times a negative 5y, which gives me a negative 25y squared. So that's going to be the final part when I go through. The reason that I like to write the xy and as xy here as well instead of yx is just so that it's obvious that those terms in the middle actually have the same variables and the same powers, so they're totally fair game to add together. So I still have the 4x squared up front. Negative 10xy plus 10xy is 0xy. and then minus 25y squared. Now keep in mind, if you multiply anything by 0, it's gone. So the best or cleanest way to write this would be 4x squared minus 25y squared. All right, let's try another one here. We've got a group being multiplied by another group, so we have to make sure that we use the full blown out distributive property. We're going to start by multiplying the 3x times each part. 3x times 5x is 15x squared. 3x times 1 is plus 3x. Minus 2 times 5x is minus 10x. And minus 2 times 1 is a minus 2. I am left with some like terms in the middle. 3x minus 10x is a negative 7x. So I end up with 15x squared minus 7x and bring down the minus 2. For the last one, I have x plus 1 as a group, and this is being multiplied by 2x squared plus 3x minus 5. Now keep in mind, we're not multiplying binomials this time. We have a binomial times what we call a trinomial, because it has 3 terms. But regardless, the process and thinking that we do is exactly the same. The term FOIL doesn't help us very much because we do have more than 4 multiplications we're going to have to do, because this x up here is going to have to be multiplied by all 3 of these. And this 1 here is going to have to be multiplied by all 3 of those. So I have to do a full rainbow of multiplications here. So let's go through and do each of these. So we start out with x times 2x squared gives me 2x to the 3rd power. Then x times 3x gives me plus 3x squared. Then x times minus 5 gives me a minus 5x. So that's what I get by multiplying the x by each of those 3 terms inside. Then I have to multiply the 1 by each of the terms in the second set of parentheses. So the 1 times 2x squared is 2x squared. The 1 times 3x is plus 3x. And the 1 times minus 5 is a minus 5. So I have 6 terms that I get after I distribute out to get rid of the parentheses. At this point, we just want to see if there's any like terms that we can combine. Again, by way of convention, it's a good idea to start with the highest power of x first. So I have a 2x cubed. That's the only term with an x cubed in it. Then I have a 3x squared and a 2x squared here. So I can combine those to get 5x squared. Then my next lowest term of x is just plain x's. I've got a negative 5x and a plus 3x. That'll give me a negative 2x when I put those together. And then I can wrap it up. There's a minus 5 still in my final expression, so that will have to be brought down and included as part of my answer. It doesn't have any like terms to combine with it. So 2x cubed plus 5x squared minus 2x minus 5 is going to be my most simplified solution, and I've been able to break out of the parentheses here with this multiplication and then write it out as a nice little polynomial.